Welcome to another video in Module 1. This topic will be focusing on data transfer concepts. The classification of data transfer is in three types, right? The three different types of data transfer are register, bus, and memory transfer. Okay. Getting to register transfer. So the most basic concept of register transfer is that the registers, okay, are denoted by capital letters. Fine. Example MAR, memory address register, SP, PC, R1. These are all different ways of representing or naming computer registers made up of flip-flops numbered from 0 to n-1. This basically means the bits, okay, how many bits the register is, and 0th flip-flop is the least significant position. So these are two ways you can represent a register, okay, either naming it R1, writing the name R1 on top of the register, or you can write the bits, okay, from 0 to 7. That means this is an 8-bit register. The register transfer concept basically involves transferring data from one register to another, okay, symbolized by an arrow. So if you are transferring data from R1 to R2, you're going to write R2 arrow R1, right? The symbol over here shows that the contents of R2, okay, are being replaced by contents of R1. After transfer, the rule is that R1 does not change because there was no change made to it. Instead of transfer, it can also be called copying, since we are just copying the data from R1 into R2. There is also conditional register transfer, where a condition may depend, the data transfer may depend on the condition that is set. This can depend upon any control signal, for example Q. If Q is 1, then we will transfer from R1 to R2. This means that Q, okay, R1 to R2 transfer whenever Q is 1. If we have the condition that Q is 0, then we just put Q bar or Q dash. That will show that when Q is 0, then we transfer. This shows the timing and control. So the control circuit, okay, the R2 register and the R1 register are connected to a single clock, okay. Control circuit determines the Q, the condition that we decided earlier, okay, which is loaded onto R2. So if Q is positive, if Q is 1, sorry, R2 will have the data of R1 transferred into it, okay. If they are happening at the same time, they are shown by commas. That means if at time t, okay, R1 is transferred to R2 and then R2 back to R1, this means in the same cycle this is happening, that is time t. So these are the summarized basic symbols of register transfer. That is, in order to denote a register or name it, we use capital letters, and numerals can be used. Parentheses are used to denote a part of the register, such as the bits or the significant bit. The arrow describes the transfer of information, and comma separates two micro operations that might be happening at the same time. Bus transfer. This is the second type of transfer. Since transfer from memory or from register to memory, there has to be a path for data to be transferred, since it cannot be transferred directly, okay. So a bus transfer is basically a group of wires, okay, and these are referred to as a common bus system. So basically the bus structure is a set of common lines, one for each bit of a register. The control signals decide which register is selected by bus and for a particular register transfer. Sorry. This is a common bus example for 4 registers, 4-bit each. So you can see there is register A, B, C, and D, and each of them has 0 to 3 bits, which is 0 to n-1. So we have 4 bits each. For a common bus system, we're going to be using multiplexers. Since we have 4 registers, we're going to have 4 multiplexers, okay. And the size of the multiplexer or the classification will be dependent on the bits of the register. So if we have 4 bits, it will be 4:1 multiplexer, and a 4:1 has 2 selection lines. For each mux, a single mux will get all the bits, will get a single bit from each register, okay. So mux 1 will have we can say mux 3 over here, as it shows, will have the 3rd bit of A, B, C, and D. Same way, mux 0 will have the 0th bit of A, B, C, and D. one will have the first bit, and so on. These selection lines help us choose for the mux. So if selection line both are 0, then the 0th bit will be transferred from each mux. Since we have common selection lines for each mux, 0 will transfer to the output 0 0 0. Thus that means that for 0 0 for 0 0 selection lines, the A register will be transferred in each case, in each mux. When A is transferred, the common bus line output will have A as the output. Same way, if it is 1 0, then it's the third position, or the second denoted bit, okay, which is C. So C will come as the output and the common line. This is the same way. If both selection lines are 0 A, if it's 1 0 C, 1 1 will transfer D, and so on. Now when the common bus is included in transfer, we will show the transfer as follows. That, for example, register C is transferred, okay. Thus what we show is C is transferred to the bus, and then the bus is transferred to R1. Since the bus is an intermediate, now we are going to show it as the carrying bit, as the carrying register that stores data into it and then passes it on to the destination. Since the bus existence is already known to the system, the more convenient way is to show direct transfer, where we do not include the bus and show that directly data from C is transferred to R1. A three-state buffer or a tri-state buffer can also be used to show a common bus system. A three-state buffer, as the name says, has three different states: logic 0, logic 1, and the third state being high impedance. At this state, it behaves as an open circuit. The control input determines the output state. So input A and control C. So C is going to determine what the output will be. Output Y equals to A if C is 1, and high impedance if C is 0. We can draw a common bus system using three-state buffer A0, B0, C0, D0. The 0th bit of A, B, C, and D are connected to tri-state buffers, which are connected to a decoder that is used as a control unit for the buffers. When the select lines are chosen, accordingly, if the select lines are 0 0, thus the 0th bit is transferred, allowing the A0 bit to pass. Similarly, if it's 1 0, then the third bit is allowed to pass, causing C to become the open circuit, hence allowing C to pass. Here is how we can draw for A0 to AN-1. We will have multiple tri-state groups, each of them connected to the 0th bit, then connected to the first bit, then second, and so on. Each of them will also share the same decoder, since we need to give the same output to each buffer gate. Memory transfer. This refers to the transfer of information to and from the memory, symbolized by M, capital M for memory, and read operation is for transferring of information from memory to outer environment. Write operation is transferring new information to be stored into the memory. You always specify the address of memory M when mentioning memory transfer operations. Let's assume that memory unit receives address from address AR. Okay, data is transferred to the register called data register DR. Okay, so this is showing that reading data from memory AR into DR. This is how we symbolize the following process. And when we are writing data, then we'll just replace read with write. Thus that means DR is writing data onto memory location AR. Thank you, and see you in the next video.